Hello there, and welcome. My name is Danielle Hopkins, and I am an instructor with the Educational Services Department here in Redlands, California. Joining me today is Tom Bowl, who is a product engineer with the ArcMap development team, also here in Redlands. We want to welcome you all to today's live training seminar. Today, we will be discussing the process of authoring and publishing map services. We will be looking at designing map documents for use in both dynamic and cached map services, as well as a look at the communication involved in making map services possible. Each topic will be followed by a software demonstrations using ArcGIS Desktop and ArcGIS Server, along with short review and several opportunities for question and answers. To begin, let's take a look at what a map service is and how it works in ArcGIS Server. Put simply, map services give access to the contents of a map document. They allow us to provide for visualization of vector and raster data layers, interoperability with other applications, as well as providing support for geoprocessing, data access, and web editing. There are two types of map services: non-cached, sometimes referred to as dynamic, and cached. In the case of a dynamic service, the required maps are generated on demand. For a cached service, the map has actually been pre-rendered and is retrieved. The choice of service type is based primarily on performance. Cached map services will provide the best performance. Other factors in this decision include the nature of the data. Will it be changing frequently or generally staying the same? In addition, who is the intended audience? Will there simply be a group of map viewers, or will people be editing or performing analysis? Let's take a look at the process of creating and using a map service of either type. The first step is to author the content of the service. What is the data you wish to display, and what do you want it to look like? We can specify the answers to these questions through an ArcMap document. Next, we want to serve this information out as a map service. This can be accomplished through either ArcCatalog or ArcGIS Server Manager. Finally, we want to use or view that newly created map service. We can do this through many different client applications, including a web application, ArcGIS Explorer, ArcGIS Desktop, ArcReader, and many, many more. Let's take a look at each of the three steps in a demonstration. So what I've done is I have prepared a basic map document. This involves some data for Corvallis, Oregon. And I'm actually going to be focusing on an application for people to be able to view bicycle lanes and the locations of bicycle shops. So I've got some special data that I've added in for that. Now you'll notice in this map document, as I zoom in, I get more and more information being displayed. So what I did was I took this map document that I created, and then I created a service from it. So if we look down here on the left, in my connection here to my ArcGIS server, and in my map services folder, I have a Corvallis basic service running. And I can actually preview it in ArcCatalog and again interact with it. So this time I'm looking at a map service that contains that information from my map document. Again, you see the same behavior as we did in the map document. So then what I did was I used the out-of-the-box tools to create a web application. So this is just the simple template working through the wizards that are included with the ArcGIS Server Manager. As I look at this, I have a navigation panel, and I also have a zoom in, zoom out, and panning option. So I zoom into my data, and again, you see the same behavior occurring here as did with my service in ArcCatalog and in ArcMap. I can navigate so I can pan around this map, and then I can return to the full extent of that data. So exactly what was happening as I was interacting with the bicycle transportation web application? Each time I zoomed in, out, or panned the display to a different area, I was asking the server for a new map. That request for a new map was sent to the server where the components of the server are hosted. An ArcGIS server local or internet connection is made to access the server components. This is where the request will initially meet the web server, which hosts the web applications and services that are based on resources running on the GIS server. Next, the GIS server will use those GIS resources, such as the map document, and put together the information requested. At this point, that information is called a response, and it is sent back to the client. Imagine this cycle continuing to occur each time the users are interacting with the service. To break this down a little further, I would like to tell you a bit more about the GIS server. Now, bear with me, as an understanding of this process is ultimately going to help us think about what we can do in our map documents to help in this communication flow. The GIS server is made up of the SOM and the SOC. The SOM, or Server Object Manager, is in charge of managing all of the requests that are coming in from the client applications. The SOCs, or Server Object Containers, are responsible for processing the requests and getting the responses ready. In the case of a map service, this happens using a special object called the map server. The map server could also be thought of as your map service if you like. This map server uses some finer-grained ARC objects to assemble the information requested by the user through rendering, labeling, projecting, etc., the data that's referred to by the map document. This is the standard communication flow for the requests being made for new maps by the users. There are opportunities for optimization at several points in this flow. However, we will be focusing on the authoring stages of the map document. This will allow us to optimize the map service we are creating by controlling the amount of processing the map server will need to do and when. In this section, we have learned that map services allow for data visualization, interoperability, and support GIS functionality. There are two types of map services, cached and non-cached. There is an important communication flow involving the components of the ArcGIS server. I'd like to take a moment now and pass things over to Tom, who will answer some of your questions.
Thanks, Danielle. Let's start our first question off. Daniel from Cleveland asks, can I use custom layers or custom fonts in the maps I serve? The answer is yes, Daniel. You can use custom layers, custom fonts, providing that the information needed to render those custom layers or custom fonts is accessible by the SOC machine. So if you have a distributed environment and have your ArcSOC on 5 different machines and you have a custom font, you'll have to make sure that custom font is on all 5 machines, all 5 SOC machines. Andrew from Boston wonders if map rotations are supported. Andrew, map rotation is supported, but remember, once you serve the map, the users of that map service are likely to be placing that map service in their own map. And it's that secondary map that they're using. If it's ArcMap, it'll start off with its own map rotation. So the map service itself will be then rotated to 0. You're able to put in your own map rotation and the server will adjust accordingly. The one caveat with map rotation is in creating a cache, you will not be able to create a map cache from a map that is rotated. Let's go next. Emily from Honolulu asks, can I access data from a map service? The answer to that question really depends on what you mean by access. If you want to query features and get to see their attributes like you would from using an identify tool or a find tool, these things are very much supported. But you have to remember that the service administrator has the ability to block these capabilities, to put restrictions. But if they're not putting any restrictions, these are supported right out of the box, and clients should have no problem utilizing this functionality. If you want to get something a little more sophisticated and actually get to the data, you can do that. But if you're using ArcMap as a client, you won't be able to do this without a corresponding geoprocessing service. What I'm saying is, if you really want to get to the geometry, to the features themselves that are underlying the map service, you're going to need to do that with extra work. You just can't do it out of the box with a map service. Let's see what else we got here. We've got Teresa from Miami wants to know if she can use cartographic representations in her map and whether these are going to slow down the performance. I've got good news for you, Teresa. You can use cartographic representations in your map, and they will not affect performance. So, don't worry about that. They'll perform, very similar to other types of rendering in your map. I believe we have time for one more question. Let's see, trying to find a good one. Abigail from San Francisco asks, can I serve layouts? Yes, with a caveat, Abigail. Layouts, that functionality is only accessible through a LAN connection through DCOM. You cannot access an ArcMap service layout through the map server WSDL. If you want to access it through the internet, like a web application, you're going to have the web application reside on the web tier. Again, utilizing ArcMap as a client, you're really starting with a new layout. So adding a map service to ArcMap, you cannot access the layout of the map service. You're really adding a new layer and creating your new layout. That's all the time we have for this section. I'd like to pass it back to Danielle.
Thank you. Well, this section that we're moving into now is going to be about authoring map documents for a non-cached or dynamic service. Let's remember that communication flow we learned about in the previous section. The client initiates a request. That request is passed to the web server and then on to the GIS server to be processed. In this process, the map server will be accessing the data and putting it all together as specified in the resource map document. One approach to map service optimization is to decrease on the number of tasks that the map server needs to do. How can I do this? Well, by simplifying the map document. We will consider this in terms of the map, the symbology, and the text. First of all, simplifying the map. Things to avoid include on-the-fly projection of the data. Store your data with the same spatial reference. Remove unused layers and information from your map document. Highly detailed features take longer to draw. At full extent, is that curvy coastline detail really necessary, or could a generalized coastline do the job just as well? So be sure to use data that is appropriate for the scale being displayed. You might find definition queries helpful to accomplish this. The use of field and spatial indexes will help in the data retrieval for any queries being performed on the data. The application of scale dependencies to turn layers on and off or to control their rendering is a great technique for features and labels alike. There are some general principles for map design that apply to all symbol types. Minimizing in the use of cartographic or multi-layer symbols, labeling, and bitmaps for picture-based symbols will help in your map performance. Solutions to these issues would be the implementation of simple symbols, symbols from the optimized style, included with ArcMap, annotation rather than labels, and perhaps the use of a Windows Enhanced Metafile, or EMF, for fill symbols. Let's examine each of these subjects in terms of their geometry type. First, marker symbols. Complex shapes or multiple layers in a marker symbol will impact the time it takes to render. In the case of marker symbols, the use of special effects such as halos, transparency, masking, and the application of offsets and large symbol sizes can really add up. If you feel that these effects are necessary, one suggestion is to create an EMF file for the symbol and then create a picture symbol with the EMF file instead. Similar principles apply to the line symbology too. It takes more time for the map server to render a cartographic line symbol, particularly if it has many layers to it, than it does a simple symbol. Choosing line symbols from the ESRI optimized style can help you make good choices for your map service performance. This style was developed using the same principles we are talking about here in this seminar. You can see in this graph that the use of offsets and wide line widths when working with cartographic lines can be significant. So as you see down here, the dash dot dash with an offset and then a wide width will take quite a bit longer to return than if you had simply applied an offset or used some sort of a variation in your symbol. So these trade-offs here are what you're going to need to decide about as you work on designing your map document as to what you really want or need. As with line features, the use of cartographic outlines and multi-layer fill symbols for polygons can impact your performance. The use of solid fills without outlines is one idea, or for something more interesting, you could again look to the ESRI optimized style. Another good choice when it comes to fill symbols is the use of EMF files versus using a bitmap for picture fill symbols. This is especially true when the bitmap image being used is a single color bitmap or a 1-bit image. When looking at text symbolization, the use of special effects will again impact the speed of your map service. Having to render serif fonts, additional backgrounds, and fills will take the map server additional time. You can help in this by trying out lighter background colors, wider line spacing, and smaller font sizes to clearly add text without affecting your performance. The use of a drop shadow on a label can really enhance text appearance with almost zero performance change. An even better solution to text is the use of geodatabase annotation rather than labels. At the very least, reducing the use of labeling, particularly that involving Maplex and complex SQL or VB scripts, will have a significant effect on the map service. You will find a number of hints on improving the drawing performance of your map documents and therefore your map service in the ArcGIS desktop help topics for each type of symbology. Let's take a moment to review a map document that I have prepared and consider what types of things we could change to improve its performance once it has been published. So if I move down here, I have another map document that I prepared for non-cached here. And again, we're working with the Corvallis data. And you might notice that I've got quite a few features that are being displayed at my full extent. Even as I zoom in, you'll notice that I've got these little brown building layers appearing here. And these are actually part of my historic places group layer that I wanted to be able to show. So over my table of contents, if I go into the historic places, what I'd like to do is apply a scale dependency to this particular layer. Actually, not even just to the layer itself, so the buildings in the district, but I'm going to apply that dependency to the whole group layer. So if I go into the group layer properties, and on my general tab, I can say not to show this group layer when I'm zoomed out beyond 1 to 20,000. So if I apply that change now, you do not see the buildings being displayed because we're out beyond that scale. If I zoom in now to 1 to 20,000, they're now being added in. Now, since we're focusing in on our bicycle transportation, I wanted to show you here a little bit of information about my bicycle lanes. But if I click on the symbol for bicycle lanes, then here what you'll see is that I'm actually using a cartographic line symbol. I can get the same look and feel if I work with a simple line symbol. I can get the same color, and I can adjust the line width to be what I had with the cartographic. So this will help a little bit with our performance in the use of the simple symbol rather than the cartographic. Now, if I zoom in a little bit further to my map display, you'll start to see that I have some labeling that appears. And I have quite a few special effects on this labeling, and I'm using not a fancy font, but one that does include some of the serifs and decorations, such as this Times New Roman. Now, on my General tab, I'm going to go in and show you some data frame properties that are relevant right here. So if I right-click on my data frame properties, and I look at the General tab, I have a reference scale that's been set of 1 to 35,000. So this is the point from which all my symbols and text are going to be scaled from. But what you'll also notice here is that I have a label engine specified, and I'm working with the Maplex label engine. I'm going to change this over to the standard label engine since I'm really working with something a little simpler. So I'm going to apply that change and say OK. So now you'll notice that, or you may notice that some of the placement of this text has changed a little bit. So we're going to go in and look at the properties for this labeling a little further. So I'm going to go look at the properties for my bicycle lanes on the Labels tab. The first thing that we want to look at is the fact that I'm actually using an expression to label these bicycle paths. And that expression is made up of 3 different fields of information. Now, if you're able to, it might be a good idea to create one field that contains all of this information. So I created a field called full name ahead of time that contains all of this. Okay, so I'm going to label using full name. Now what I want to do is change what my symbol is going to be. So as I move into here, you might have noticed that white outline. That's actually a halo effect on my text. So I'm going to remove that, and now I'm going to change my font to something a little simpler, such as an Arial font, and I'm going to make it a little smaller for this map scale. Finally, since I moved into the ESRI standard label engine and not my Maplex anymore, I want to confirm that I've actually got my label placement above the line, and in this case, I don't need to apply any kind of an offset to it. Now, the last thing I want to draw your attention to is the fact that I can not only set scale dependencies or scale ranges on my layers and my group layers, as we saw with the historic information, but I can also do this for my labels. So I've actually got a setting here, 1 to 15,000, so that my labels are not displayed at all of the different scales. All right, so I've applied those changes and you can see them reflected here in the display area. Now, what you could also do is convert those labels into annotation if you wish, using a right click. So that'll have to be something that you can explore as well. But the simpler labeling is going to help in your performance. Now, one more thing I want to show you is the use of the ESRI optimized style. So over here, I've got some parks that are being symbolized with one of the ESRI standard symbols. So if I right-click and go into my properties, I'm actually going to look at my symbology tab here, and I'm working with, like I said, that ESRI standard symbol set. So I'm going to go in here, and up above the screen, I'm actually turning off the ESRI standard symbol set, and I'm going to turn on the ESRI optimized. Now what you'll see in here is that I have got a series of symbols that are very familiar, but they've been, like I say, optimized for web performance. And I've actually got the very same symbol, but available in that style. So I'm going to switch over to that symbol. And I also had the option there of removing the outline if I want to as well, and playing with that. So I'll apply that change, and then I'm also going to go over onto the General tab and set up a scale dependency for this layer as well. And here I don't want it to display out beyond 1 to 35,000. So I'll apply these changes, and now when I zoom to the full extent of my data, you no longer see those historic buildings or the park areas. Now I want to save this map document out, so I'm going to say File, Save As, and I'm actually going to save it right here in my directory and keep it with the name Corvallis Non-Cached. So I'm going to want to come back to this in a few minutes and take a look at the process of publishing this out for use. So for best dynamic map service performance, keep the map document simple. Remove extraneous information. Use simple symbology, text, and features. Use the ESRI optimized style. In general, you can think about this principle. If it draws slowly in ArcMap, the map service will perform slowly too. Now, you do not have to compromise your advanced cartography for a map service. You can create a cached service, as we will see shortly. Let's take this opportunity once more to answer some of the great questions that we see coming in. Tom?
Thanks, Danielle. I'd like to start off with a question Andy has. Andy's from Shreveport, and Andy asks, does ArcMap use the optimized style by default? No, Andy, ArcMap does not use that style by default. You'll have to manually go in and make those changes. Christopher from Portland has a question concerning the optimized style, and he's asking, why are there no marker symbols in this style? The marker symbols that we have are currently the most proficient that we can make right now, given the software that we have. So go ahead and feel free to use the ESRI style marker symbols and simple symbol set. Nancy from Boston asks, do group layers help improve performance at all? Nancy, group layers do not affect performance at all. We view group layers as an excellent management tool. If you're working in a large organization and you're passing layer files around, you may want to consider, grouping everything together and creating, one layer file from the group. That helps out quite a bit in distributing your work. Lance from Ann Arbor asks a question, are my ArcGIS server maps going to be faster than my ArcIMS maps? Lance, there's a couple things to this question. It really depends on whether your ArcGIS server map is a cached or a non-cached map service. If it's a non-cached map service or dynamic map service, in general, it will be slower than your ArcIMS map service. However, if your ArcGIS server map service is cached, it will be faster than the ArcIMS map service. Let's go. We have a user is asking, can we dynamically add layers to the map from ArcSDE? Yes, you can do that, but you're going to need to do that at the server tier, at the web tier. You're going to have access to the fine-grained Arc objects in order to change the state of the map that's being used in the map service. You're probably going to want to do this with a non-pooled object. For those that aren't familiar with pooled and non-pooled objects, a pooled object is shared. All the instances within that pool is shared amongst different users. A non-pooled is not shared. So if you're doing stateful changes to the map service, you definitely want to use a non-pooled object. Now, a non-pooled object will not perform as well as a pooled object, especially in an internet or through the internet. So you'll probably want to use a pooled object unless you're going to do heavy duty stuff like adding layers, really changing the state of the map. And there you'll have to do it you should use non-pooled objects to do that. I think we have time for one more question. Let's go to so many good questions. Kelly from Austin asks, what are my map services by default, non-cached or cached? Kelly, the map services by default are non-cached. You will need to utilize a map service in order to create a cached map service. I'd like to take this time to pass it back to Danielle.
Thanks very much, Tom. Well, let's take a look at publishing map services, and then we'll spend some time on cached map services. So now that we've worked so hard to create a well put together map document, we want to make it available for use by publishing it using ArcGIS Server. Publishing a service means that you are making the information, in our case the map document, available over the web. We have two options for where this can be done: ArcGIS Server Manager or Arc Catalog. In both environments, you can publish a service directly from the resource, or you can add the new service to the server. Once you have specified a name for the service and the map document that will define it, you will be asked for the capabilities you wish to enable. A panel with a list of options will appear. This list will vary based on the resource you are publishing. The mapping capability will always be enabled when you are publishing a map document, thus giving access to the contents of that document. The WMS capability allows for the map service to be implemented in applications that use the OGC or Open Geospatial Consortium's Web Map Service specification. This relates to the interoperability characteristic of map services published using ArcGIS Server. The mobile data access capability allows for data to be extracted from the service to a mobile device, and the KML, or Keyhole Markup Language, capability allows for interoperability of ArcGIS Server map services with applications that read KML. Properties set on layers in the ArcMap document can be published in a KML application. The properties of a service, once it is being created, may be edited by stopping the service. Edits are made and the service is restarted once again. There are many properties for the service that can be set, including the pooling, timeouts, isolation, and recycling. All of these properties provide some opportunity for some fine-tuning of the service, and are explained more thoroughly in the ArcGIS Server Help in the Tuning and Configuring Services topic. We will now take a few minutes and publish the map document we created in the previous demonstration. So if I come down and I take a look at my ARC catalog, what I'm going to do is look for that map document that we just created. So I need to just refresh that display, and now I can see my new non-cached map document. And I can right-click on that map document and say, Publish to ArcGIS Server. When I do this, the first thing I need to give is the name of the service, which I'm just going to keep as Corvallis non-cached. Now I can put that service inside of an existing folder or not in a folder, and I can even create new folders. And this is just a way to organize your services. Next, I have those capabilities that we discussed in the lesson. And finally, I get a short summary panel about what's going to be made. So I come down here to my GIS server, and if I look in my Map Services folder, I can see that I now have the Corvallis non-cached service. And if I look at it at full extent, I'm going to see the full extent of the city of Corvallis, and then I can use my zooming in and out tools in order to be able to display more or less information. Now, I mentioned that there's an alternative approach. So I could either go to the resource like I did, the map document, and publish it, or I can go to my server. And I can say here, add a new service. In fact, you can actually even go to the folder and say, add in a new service. Either way results in a map service being created. The second might take a little longer as you're setting up the properties during the service creation. It's important to know, however, that those properties, as I mentioned, can be changed at a later time if you wish. So let's take a look at the properties for our non-cached service. If I start over here with our General tab, I can see that I have the name of the service and what type of service it is. Next, I've got my parameters. So it specifies what the resource document is that's defining the service. And then it has several output directories that we'll be using a little later on if we decide to cache this. Now there's a capabilities tab here. So if I had stopped my service, I would be able to change these capabilities. Notice that there are also operations allowed. So you decide what is going to be able to happen using this map service. Now, there's also a special pooling tab here, and Tom mentioned about pooling. Essentially, pooled services is where we have a group of instances all together and we access those instances. If it's non-pooled, then we have a dedicated instance for the user. Now, we also have the ability to set up some timeout values for how long our clients will wait for responses. And we also have recycling settings as well as how we want each one of our services to run on the host machines under this processing tab. So like I said, there's a lot more information in that server help topic that I mentioned. Now, on the caching tab, we've got a directory that's been specified as well as some opportunity to generate that cache. So I'd like for you to remember this as we go through the next section. One thing that I would like to mention here and that has come up is that if I make changes to my map document, so for example, if I change the symbology for my parks or for my bicycle lanes, maybe I change the color or I add in more layers, then I would need to go and stop my service and restart that service in order to see those cartographic changes. If there are changes to the data in the database for my map service, in the case of a dynamic service, that's what's going to be displayed. So the new features would be shown. So I just wanted to make sure that that was clear as well. All right. So in review, We publish the map document to create the map service using Arc Catalog, or we could have used the ArcGIS Server Manager. Now we will spend the last section of the presentation looking at authoring for cached map services. First of all, what is a map cache? Well, as the name implies, this is a set of images that are rendered in advance at predetermined scales and hidden away for later use. Based on the scales chosen, a folder hierarchy is created for the images and the extent of the data divided based on the specified tiling scheme. I'd like to talk a little more about that communication flow we learned earlier. A request is made by the client or user and sent to the web server. Now, rather than going to the GIS server to get the data directly, the web server is going to look for a cache directory and retrieve the image of the data that was pre-rendered. This is much faster than working to find and render the data for each request individually. Now, don't be concerned here, as we can still identify, query, and search the data by accessing the GIS server in these cases. So the decision is, do I want to create a cached service or not? As mentioned earlier in the presentation, a cached service really is going to give you the best performance. They work best for complex base maps and imagery, along with the data that isn't going to be changing very frequently. I might not choose to cache a data layer if the information changes by the hour or even daily. Perhaps the data is being rendered based on attributes that are changing often, and I'm going to be editing the data through a web application. Under these circumstances, I might not use a cached service for these layers. But I want to be clear here that you can bring together several different services in one application or in one client. So it is entirely possible for you to divide your information so that you can create a cached service for data layers that will not be changing frequently, and then have another service that has just those layers that will be changing or very dynamic. So the benefits for this caching process, although it's an investment, really are great in terms of the performance as well as the cartographic quality that you can implement. Based on what we've learned, I might use low resolution relief, more solid colors, and annotation in my dynamic service, where I could more easily use my detailed shaded relief data, transparencies, Maplex labeling, and more if I were caching the service. I'd like to spend a moment and evaluate the process of building the cache. As with any project, the preparation stages are very important. Allocation of resources, decisions regarding the cache type and schema, as well as the cache scales will need to be determined. Next, you will need to create and test the map document. Following this, you will need to conduct a small pilot project to evaluate your planning and map document, as well as by generating the full cache. Let's take a look at each one of these steps and see some of the ideas and considerations for each. Since we are generating a directory full of images, we want to consider the storage space and the time to generate or render the files. Caches can take anywhere from a few minutes to a few hours and sometimes days to generate, depending on how much data you have. So you can see that a little planning and testing will be helpful. There are two types of caches: fused, where one set of images is created for all of the layers, and multi-layer, where a set of images is created for each of the layers. For best performance, fused caches are recommended and commonly used. We suggest overlaying two separate fused map services rather than using one multi-layer. Next is the tiling scheme. You should use one tiling scheme for all services that will be used together. This scheme consists of an origin, a tile height and width, as well as the file format for the images. Another important decision. Finally, there is that decision as to what scale levels you will create the cache at. This choice is a very important one, as it will not only affect the creation time and storage size of the cache, but also your user's map service experience. In some cases, this is what will limit the scales at which your users will be able to view the data at. So you want to be sure that your users are getting the information they need. Some suggestions for deciding on your scale levels include first determining the scale that the closest scale that the user will need. Next, take this scale factor and double it until you reach the scale of the data extent. Another option is to match the scales to the other services that you will be using. For example, if you are going to incorporate some of the ArcGIS Online services, you could cache your service at the same scales. As you can see, ArcGIS Online uses some very specific scale levels. Please refer to the ArcGIS Server development blog for more details as to how to do this. I will be providing more information on finding the blog later in this presentation, or you could also use that shortcut link down to the left-hand side of your screen. I now want to talk about the authoring process for a map document that will be used for a cache map service. You want to design your map document for each scale that you intend to build the cache at. The approach you take will be up to you, but you can see two examples here. The first shows a group layer created for a general layer, in this case highways, and the layer has been added, or the data has been added and symbolized multiple times for each scale level. Alternatively, you could create a group layer for the map scale and add the layers and symbolize them in there. The choice is up to you. Next, I can apply a definition queries to the layers. As you can see on the left, I have fewer roads being displayed than I do as I move in closer. A definition query, which is set on the layer in the layer properties, means that I can use the same data set, simply displaying different amounts of it at each scale. Scale dependencies set on the layers, labels, and symbology will also be very helpful. We saw how to do this in the first section of the presentation. Now a couple of tips for when you're working in ArcMap. Since we are testing the map display at our caching scales, I can now customize the scale pull down on the standard toolbar to reflect those scales. And you saw me working with those earlier, actually, as I navigated my map documents. In addition, something else very, very important I want to show you is the application of a data frame extent. This is a property of the data frame in your map document, and it is what will determine the boundary of the data the cache will be generated for. So we'll see how to use this in a minute. Next, I want to tell you a bit about setting the background color. This is an important setting for map documents that will be used in cache map services, since it defines the transparent part of the image. So if you're going to be working with several services together, some of them might need to be transparent. Now, if you do not set this value yourself, the default is a nearly white color. It is recommended to use a color that is not used in your symbology, as these are the areas that will ultimately become transparent. The last part of this is to generate your map server cache. We can use our catalog and work with the caching properties tab for the map service, as you will see in a few minutes, or you can access the server tools toolbox, where a series of tools are available for generating, deleting, updating, and generally managing your cache. So about that pilot project, create a cache for a small area of your data first. You can specify this area using the data frame extent setting I spoke of a few moments ago. Examine the cache for the appearance of your symbology, labels, and performance in your preferred client application. Make any necessary adjustments and rebuild that small area. Track the time for generating it, and that way you will be able to estimate the time and storage space for the entire data set. For further information on caching, I encourage you once again to refer to the ArcGIS Server blog and the ArcGIS Server online help. There are a number of helpful entries and topics located there for you. Let's take a quick look at a map document that was designed for cached map service and some of the caching properties that can be set. So here I've got, again, more data for City of Corvallis, Oregon, and we're using similar ideas in terms of our bicycle transportation map. But what I want to point out to you is a number of things. The first thing is that in my parks, so down here, you can see that I actually added the data in twice. I added it because I wanted to use a different symbol when I'm working at the different scales. So here you can see that my parks are shown in a solid green, but if I zoom in a little bit closer, you'll see that I'm starting to use a representation. Now, as Tom said, representations won't necessarily impact that performance, but it's just a cartographic preference that I have here. Now, with my highways, I did something similar too. As I zoom in, the highway symbol becomes a little bit narrower, and I've put different kinds of labeling on it. In fact, I don't even have it at a closer scale. And if I move out to the full extent, you'll start to see that I've got those highways labeled. Now, let's look at that data frame extent. So I right-click on the data frame, go into Properties. And here on the data frame, I can see at the bottom that I can either go with the default setting, which is the extent of all of the data that are added in, or I can use another option. Now, I have a custom extent set at the moment, but I can also go perhaps with the outline of features, and then I can specify one of the layers that I have. So perhaps the city boundary would be appropriate. So I wanted to make sure that you knew about this because this is that setting where you control the extent at which you want to build the cache. Now let's return to that Arc Catalog environment, and I actually got a service running here called Corvallis Cached. And in fact, if we look at that service properties on our caching tab, I can see that I actually pre-created the cache. But let's look at the process I went through. Up here, I have a Generate button, and this Generate is going to access the Arc Tools toolbox for the server tools. So in here, as I go through, I can see that I've actually got a lot of the fields populated because I'm doing this from the service. Now, in the middle, I have the option to specify custom scales, or I can use standard and have Arc Catalog calculate them for me. So here I can enter in values and put them into the list. Now further down, you have another important setting, and that is this cache tile format. So you've got options of several kinds of PNGs as well as a JPEG image. Now the choice of image type here is important in that some of them support the transparency and others do not. Also, the sizes of these files are different. If you click on this Show Help button here, then you can actually see what those different file formats are for and what their strengths and weaknesses are. So you've got flexibility and choices there. You have your tile width here, and then you also have this cache type. Remember that fused and multi-layer. Again, your fused will give you the best performance and is very commonly used. Now, when I run that Generate tool, what happens is that a direct folder of files was created. Now, it was put in this ArcGIS Server, ArcGIS Cache directory because this is what was configured during my installation of ArcGIS Server. You can actually generate the cache to any folder you want to, However, it needs to be in a specific place for ArcGIS Server to be able to work with it and see it when the time comes. And for us in this installation, it's the ArcGIS cache. So you'll see that I have a folder for my map services Corvallis cached service. And inside of here, a hierarchy is being created that corresponds to each one of my scale levels. Inside of this, you see the tiling scheme that's being applied, and then you get a folder full of images that have been created. So how does this translate to the user? Well, I created again another out-of-the-box application. So this is the City of Corvallis cached service. And again, I have my zoom in and my zoom out tools. And as I do that, I get more and more information being displayed. But the difference that you'll see in the out-of-the-box applications is this little zoom in, zoom out notched slider bar. So I can use this slider bar now to move in and out from the data. And again, you see the behavior from the map document. However, what we need to understand is that these notches correspond to our cache. And so this is where our users will be a little bit controlled by your decisions on the caching levels. In review, although caching does require an initial investment in planning, authoring, and generation, the benefits in performance and cartographic display are significant. I'm sure you've got some questions now for Tom, so let's take some time and address a few of those.
Thanks, Danielle. Let's start with Dustin from Townsville. Dustin asks, on a single box installation, how many socks are allowed? Really, Dustin, there's really no limit. It depends on how much memory you have on that box. If you start to, run out of memory, you can always add additional machines to your GIS server. What I'd like to do is highlight a white paper that we have. It's titled ESRI System Design Strategies. And it's available on the website. There's also a lot of information in the ArcGIS web help that should, help you figure out what kind of questions you need to ask when configuring your GIS server and, looking at what kind of hardware and what you have available. Next question. We've got Roland from Annapolis. Roland's asking, is it possible to create or manipulate caches in an ArcGIS server manager? Unfortunately, Roland, you will need Arc Catalog to create and manipulate the caches. This functionality at 9.2 is not available in the manager. Jim from Vancouver is asking, how much does anti-aliasing affect performance? And I'm assuming this is the performance in creating the cache. It will affect the performance. If you're choosing to anti-alias, your caching will take longer. Mike from Calgary asks, if you convert labels to annotation and save the anno in the map, can this still be accessed via ArcGIS server through ArcMap, Web Services, ArcGIS Explorer, etc.? Michael, yes, it'll be accessed, but I think I have to caution you about saving the annotation in the map or MXD. Depending on the size of the annotation or the amount of annotation, you could get a pretty big MXD. I would highly recommend that you save the annotation in a geodatabase. There you'll definitely have the performance benefits. It's just a much better solution. Next we have Paul from Santa Cruz asks, how will a table join perform in a cache service? Will the join persist after caching? Yes, you will have the join available because the data, unless you've done something, the data will still be available on the cache so that you can do identify, find, it'll still be available. So that join will still be there. Just make sure if that join is based on a table business table that you have maybe on a separate machine, that all your appropriate ArcSoc accounts have the proper permissions to that data. Paul from Sacramento asks, if I wanted to create a cache map service, can I set the file type such as JPEG or PNG? Is it important what you select? Where is it set? Well, as Danielle showed in her demonstration, that's set in the Generate Map Server cache dialog. The file type does matter. JPEGs are smaller, they'll be faster, but they do not support transparency. So it really depends on what you anticipate your users doing with your map service. If it's primarily for a base map, so let's say you have lots of imagery in this particular map service, then I would recommend using a JPEG. However, if your map service is, possibly street networks or something that a user may overlay on top of other data or other layers or even other services, there you'd want an image type that supported transparency. So there you'd want to use one of the PNGs. Simon from Bathurst asks, how are conflicts, i.e. symbology text, managed when using a mix of cache and non-cache services? Simon, there are no conflicts. The image that cache, it'll just draw, and then if you're, and that's got labels, and then you've got another service, and you put it on top of your non-cache service, it's independent. No software is figuring out what the conflicts are. So it's likely that you're going to have overlapping overlapping labels and overlapping text. Let's see, I have time for one more question. Let's pick a good one. Gavin from Phoenix asks, can I update the cache if some data changes? Is it very hard to do? Gavin, I've got very good news for you. Yes, you can update the service, the cache. You can do that using the Update Map Server Cache Geoprocessing tool. If this is something that you do periodically, you can create a script using Python. It's also a good tool to break up large caching jobs into distinct areas. Basically, we're trying to make the caching experience as user-friendly as possible. We understand that many users want to use cache for not only data that may never change or changes yearly, but for data that changes more periodically, monthly, weekly, and possibly even daily. And we're working very hard to make that a reality for you and to make that process the best it can be. I'm sorry, but that's all we have time for. I'd like to pass this back to Danielle for final comments. Thank you.
Thank you, Tom. Before we go, I'd like to point you to a few resources. We do have both online and instructor-led ArcGIS server training available to you. And we would also like to remind you about that server development blog that has articles posted very regularly, very interesting options for you there, as well as our support site and the online help documentation or resources that are also updated weekly to keep you with the best information and most up to date. Your comments help us improve our seminars. Please take a moment to complete our survey. Just click the Give Us Feedback link and to take that survey. We hope you enjoyed today's seminar. On behalf of ESRI, I'd like to thank you all for attending.